In this video lesson, we are discussing angle pair relationships. You're going to learn a lot of different angle pair relationships throughout geometry, but today we're really just focusing on 4 pretty important relationships, 2 of which I bet you are familiar with, and in fact, all of which you studied in Math 8. So we're going to be reviewing vertical angles, complementary angles, supplementary angles, and linear pairs. The first angle pair relationship we're going to discuss are vertical angles. Let's go over the definition. Vertical angles are 2 angles that are formed by intersecting lines that share the same vertex and are congruent. That last part about them being congruent is very important to us. So when I say they share the same vertex, if you look at these lines, these 2 intersecting lines both share this vertex at point O. So they share the vertex, and it's going to actually the intersection creates 2 pairs of vertical angles. So the first pair, or one of the pairs rather, if you look, this angle on the left is going to be congruent to this angle on the right. So I could say that angle AOC, remember there's multiple ways we can name this, but we can't call them O, is congruent to angle BOD. All right, the other pair of congruent angles that we're going to see is angle COB and AOD. So if we look, this is another pair of vertical angles, these 2. And they are also congruent. In this first example, we're going to use what we know about vertical angles to find the value of this variable y that's in our picture. We can later, when we learn about supplementary angles, find x, but for right now, we are just going to focus on finding the value of y. So we said the important thing to know about vertical angles is that they are congruent, meaning they have the same measure. So if I'm asking you to find y, and we're using vertical angles to do that, we want to first identify that this angle that measures 63 degrees is going to be vertical to this angle. So those are our vertical angles. We do have another pair of vertical angles, the unmarked angle at the top. That angle is going to be vertical to the angle at the bottom, but we're not using those right now because we don't have enough information using only vertical angles to solve for x. All right, so if we know that these angles are congruent, that means they have the same measure. So what that means is that the angle on the left, which we're going to say is y plus 23 degrees, that angle must be equal to 63 degrees. So when angles are congruent, they have the same measure. It's not really necessary to use the degree symbol in our equation. So this is a pretty simple algebraic equation. We are going to combine our like terms. So to get 23 to the other side, so our constant terms are together, we could subtract 23 from both sides. Therefore, y is isolated by itself on the left, and 63 minus 23 is 40. So in this problem, the value of y is 40. Now, remember, the angle itself is still 63 degrees. So when I ask you what the value of y is, you'll tell me it's 40. If I asked you for the measure of this entire angle, you would still tell me that that measure is 63 degrees. Our next important angle pair relationship are complementary angles. Now, this is probably a definition that you've heard of. So 2 angles whose measures have a sum of 90 degrees. Those are complementary angles. So if we look at 2 examples, what I want to be clear about is that they don't have to share the same vertex to be complementary. So in this example, over to the left, angle ABD, that angle, it's complementary to angle DBC. Now, normally, to know that it's complementary, right now you know because I'm telling you, but normally we would be looking for that right angle symbol or just some other information so that we could conclude that those 2 angles add up to 90 degrees. But this is also another pair of angles over here that are going to have a sum of 90 degrees. So they're still complementary even though they don't share a vertex. We're going to look at two examples of using complementary angle definitions to solve for a missing value or angle. In this example, you can see in our diagram that we are missing the value of x, but we know that those are complementary angles because we can see that that blue square there telling us that the big angle is going to be 90 degrees. So to find x, using the definition, we know that whatever x is, when we add 62 to that, we're going to have to get 90. So we said again, complementary angles have a sum, which means add, of 90 degrees. So now in order to solve this, it's simple algebra here. We're just going to subtract 62 from both sides of our equation. And once we've done that, we have x isolated by itself on the left, and 90 minus 62 is 28. So we know that angle is 28 degrees. The only thing that makes example 3 more difficult than example 2 is just the algebra. So we are still looking at complementary angles. We know that these two angles make a right angle, again, because of that little square that tells us. So we are going to know that these two different angles represented with two expressions have a sum of 90 degrees. So let's start by, again, writing an equation. So I know that 3x minus 15, when I add that angle measure to 2x plus 10, they're going to add up to 90. Now, I didn't use parentheses here. In the picture, there's parentheses just because of that degree symbol. We don't really need them because we're just adding and subtracting here. All right, the first thing we want to do is combine our like terms. So we could go ahead and combine 3x and positive 2x to get 5x. And then I'm going to call this a negative 15 because I always turn addition into subtraction. So this is the same as saying plus negative 15. Oops, plus negative 15. So negative 15 plus positive 10 is going to give us negative 5. So we end up with 5x minus 5 equals 90. All right, now we know that we want to still get that 5 to the other side. So I'm going to add 5 to both sides of this problem. And we now have that 5x is equal to 95. When I divide both sides of this by 5, that's our final step, we'll get that x is equal to 19. So 19 should be the value for x. That gives us these two angles, and the two angles should add up to 90. A really quick way to check our work here is to go back to our original equation, substitute 19 for x, and make sure that all comes out to 90. Let's do that real fast. So 3 times 19 minus 15 plus 2 times 19 plus 10. And again, if we're correct, that should all equal 90. So 3 times 19 is 57. I'm going to go through and do all of my multiplication first. 2 times 19 is 38. All right, so now left to right, addition and subtraction. 57 minus 15, we get 42. So we have 42 plus, that should be an 8, 38 plus 10. When we add that up, 42 plus 38 is 80, and 80 plus 10 is 90. So it does check out. Our last angle pair relationships are really similar, so I'm including them in the same slide. The supplementary angles in a linear pair. So let's look at these two definitions. Supplementary angles are going to be two angles whose measures have a sum of 180 degrees. So a lot like complementary angles, but they add up to 180. A linear pair are going to be two supplementary angles who share a vertex and a side and therefore form a line. So it's kind of a subtle difference. Let's look at these two pictures. Supplementary angles, again, if you're looking on the left, we can see this angle is 60 degrees, This angle is 120 degrees. So when you add 120, you get 180. So by definition, those angles are supplementary. They're not, however, a linear pair. A linear pair is going to be when we have two different sets of supplementary angles. So if we look here, angle LMK, it shares a vertex M and it shares the side MK. That angle is going to be supplementary to angle KMH. And because they share a side and a vertex, we call those a linear pair. So for example, let's say that angle KMH, let's say that's our 60-degree angle. We're just pretending. It looks like it's probably a little bigger than 60. If this angle were 60 degrees, this angle would then have to be 120 degrees. Now we know that they are a linear pair because LMH are three collinear points. Therefore, LH is a straight line. Again, we'll look at two examples of supplementary angles. We'll start with a pretty easy one. If you look at this picture, we're asked to find x. And we said, again, by definition, supplementary angles are angles whose sum is 180. So that means that x plus 130 must equal 180. Again, it's really simple algebra here. We're going to subtract 130 from both sides. And what we will be left with is that x is equal to 50 degrees. That's a degree symbol, not 500. In our final example, we're still looking at supplementary angles, and in fact, this is a linear pair. It's only complicated because the math is a little more complicated, but it's pretty similar to example 4. So we said if we know these are supplementary, their sum must equal 180, so we could write the equation that our first angle, 3x minus 20, plus our second angle, so plus x, must equal 180. All right, so let's go ahead and combine our like terms. So on the left, we could combine 3x and x. We're going to get 4x. There's not another constant term that we can really combine on the left right now. So we have 4x minus 20, and that's going to be equal to 180. All right, now we know we want to work backwards, so we want to get rid of that subtraction of 20. We're going to do that by adding 20 to both sides. And we're left with 4x equals 200. And then divide both sides by 4. X equals 50. So I didn't plan it this way. This was not on purpose. But it turns out that this angle is 50 degrees. And then if I asked you to find this angle, because they're supplementary, we've got to think that it's got to be 130 degrees. So a quick way to check our work is to think, if I take this value of 50, and if I substitute that in over here for x, is 3 times 50 minus 20, is that equal to 130? Well, 3 times 50 is 150. When we subtract 20, we do get 130. So good news, it checks out. You made it to the end of the lesson. Don't forget, I'm expecting to see all the examples and definitions in your notes, and you may always rewatch the video again if that's helpful to you.